Okay guys, today we're talking about linear equations in two variables, okay? And I've written a couple of things up here because I didn't want to forget to talk about them, but also as a good example. This thing here on the right, we know this. We've talked about this 100 times, right? I'm going to divide both sides by 2 and I get x equals 4. That's the solution. X equals 4, it doesn't equal 5, it doesn't equal 3, it doesn't equal 4.1, it doesn't equal negative 12, it can only be 4. That's the only thing that solves that equation, okay? And if I were going to graph it, I'd draw a little number line, I'd put 4 here, I'd put a dot on it, right? Like 4th grade, isn't that nice, graphing that stuff? Okay, and this would be 3, and this would be 5, it's all pretty. Nice, okay? Now we're going to go into the 7th grade, and we're going to talk about this equation. X plus y equals 7. This thing has one solution. Well, when I start looking at this one and coming up with solutions, I'm going to find an interesting thing. It could be 0 plus 7. It could be 1 plus 6. It could be 2 plus 5, 3 plus 4, 4 plus 3. It could be, I could go negative on you. It could be negative 1 plus 8. I could go fraction or decimal on you. It could be 6.9 plus 0.01 or 0.1, right? There are an infinite number of solutions to this equation. Infinite. All right? And just for Arjun's sake, there you go. The infinity sign. You like it. Okay? Now, talking about that equation, we've got a lot of combinations. We have an infinite number of combinations that give us 7. Okay? So how do I graph that thing? This one over here I graphed. It was just on one number line, right? But I've got two variables here. We're talking today about linear equations in two variables. So that means I need two number lines. I'm going to need an x and a y. And I want to talk about graphs for just a second, guys. A graph is a picture of all of the solutions to an equation. It's a picture of all of the solutions to the equation. If you look at this simple one over here to the left, that's a picture. It's just a dot, but that dot represents the solution. How do I represent the solutions for this thing? Because I've got an infinite number. Well, we've talked about graphs. We know that they're the picture of all the solutions to an equation. I need what's called a table of values. It's also known as a t-chart. Okay? You need more vocabulary. Those things are synonymous. T-chart. And with a t-chart, draw a little line here. A t-chart looks like this, x and y. All right? And for me, I always use for my input, right? I use negative 1, 0, and 1. Because they're small numbers, I've got a negative number, I've got a positive number, I've got 0. And they're small numbers, they're easy to work with. Okay? So when I plug that in, I realize, oh wait, negative 1 plus 8 equals 7. 0 plus 7 equals 7. 1 plus 6 equals 7. Each one of these is a solution to that equation. They also represent a point. Let's think about this. Negative 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to extend this line a little bit. So that's going to be 2, 4, 6, and then 8's up here. Guys, negative 1, 8 is right here. 0, 7 is right here. You guys know how to plot points. You know how to graph. 1, 6, it's right here. Man, this is making a very interesting picture, Mr. C. It is. It is. I hope you're seeing that. That's why it's called linear functions, right? Because it comes from, their graphs are lines, okay? They're always going to look like that. Okay, the last thing I want us to talk about today is function form. This equation, x plus y equals 7, is not in function form. To get it in function form, I have to get y by itself. So I'm going to subtract x from both sides, and I have y equals, and I always put the x term in front and the constant in the back. This is now in function form. And it helps us with graphing later, but I wanted you to be able to do that. And we'll talk about it with one of the examples. But got through all the stuff today, and I've got about 15 seconds left before YouTube cuts me off. So good job, guys, and I'll see you in the examples.